Today I'm going to tell you a little bit about the periodic table. There's lots of different ways to divide up the periodic table. One way to divide it is to just look at metals, metalloids, and nonmetals. And so you can see here by the color coding that the left-hand side of the periodic table are all considered metals with the exception of hydrogen. And the right-hand side are the nonmetals. And then in between are the metalloids. This block down here, these are also metals. They're supposed to slip inside here. They're kind of put down there as a footnote to the periodic table. So just in general, metals are shiny. They're conductive. They conduct electricity. They're ductile, which means they can be pulled into wires. They're malleable, which means they can be pounded into sheets. And importantly for chemistry, they form positive ions, generally speaking, when they're combined with other atoms. So when you think about the left-hand side of the periodic table, these will form plus ions. Nonmetals, on the other hand, are all the opposite. So they're dull, they don't conduct electricity, and they're brittle. And they form negative ions. So that's going to work out. The metals are going to make positive, the nonmetals are going to make the negative, and then they'll combine together to make ionic materials. Then the metalloids, they're in between. So sometimes they act like metals, sometimes they act like nonmetals. It really depends on the situation. So you can't say that arsenic, for example, is like a metal or like a nonmetal. It's going to depend on what other atoms are around, what role it will take on. All right, let's look at the individual columns in the periodic table a little bit. So especially this first column. This first column is called the alkali metals, and you don't have to memorize that, but I'll probably say that from time to time, or I might just say first column. This is the most reactive of all the metals. The metals in this column are the most reactive. And this is something you should remember. They typically form +1 ions. So they lose one electron to make +1 ions. And we'll understand why that is later when we talk a little bit more about atomic structure. The second column, these are called alkaline earth metals. Again, you don't have to remember that, but I might say it. These are not as reactive as the first column, but they're still quite reactive. And they typically form +2 ions. That is something that you should remember. So first column +1, second column +2. If we go to the middle of the periodic table, this whole block in here, sometimes called the D block, but more often these are called the transition metals. So you can remember these are the transition between the alkali and the alkaline earth metals and the nonmetals. So they're in between metals. They're not as reactive as first and second column, which actually makes them more useful in a lot of ways. If you want to build a bridge, you're going to use things like iron and manganese, cobalt, and nickel. You're not ever going to build a bridge out of sodium or calcium because those are very reactive. And so if you build a bridge out of iron, it's going to be much stronger. It won't fall apart just sitting in the water. Well, it will eventually, but not nearly as quickly. Kind of the interesting but sometimes tricky bit about the transition metals is they form a wide variety of ions. Everything from +1 to +7 ions, and that could even be for a given atom. So for example, iron can form +1, +2, and +3 ions depending on the context. So unlike column 1 and column 2, there's nothing to memorize about what ions these form, but that also means you can't easily predict what ions they're going to form, and we'll have to look at the context to figure it out. All right, let's go to the nonmetal side of the periodic table. The last column in the periodic table, these are called the noble gases. These are non-reactive, so with some very rare exceptions, they just do not form molecules. They stay by themselves. In this way, they're noble, like they're above it all. They don't participate in chemical reactions. They also are gases at room temperature, which you probably know helium is a gas that you're familiar with, but all of these other ones make gases at room temperature. Yeah. The second to the last column, these are called the halogens, and I will call them that sometimes. Again, it's not something you have to memorize, but you probably will hear that word and start to become familiar with it. The halogens are very reactive, so even though they're right next to the column that's not reactive, these are the most reactive of all the nonmetals, and they form -1 ions, and that's something that you'll need to remember. This column makes -1. And again, we'll understand later, but just to give you a little bit of a preview, if you think about how unreactive neon is, if fluorine wanted to be like neon, it would only have to gain 1 electron. So -1 with 1 extra electron, and then it would be stable, like a noble gas like neon. All right. Down here, this block that slips in as a footnote, these are called the inner transition metals. Sometimes they're called rare earths. These are often rare, not always. Some are quite common, but some are quite rare. Some even have to be synthesized using a super collider. They don't occur naturally. And often they are radioactive. So you can see things like uranium is in here. That's a radioactive element that's often used in reactors. And then there's also plutonium here. That's used in nuclear weapons. Americium here is radioactive, and that's inside your smoke detector. And I'll describe sometime how a smoke detector works using the radioactivity from americium. All right, there are, I already mentioned some elements that have predictable charges, certain columns, like the first column forms +1, second column +2, the halogen column -1. There are some other ones, so we could call this the oxygen column, because oxygen's at the top. This column forms -2, and then nitrogen forms -3. One other one that you'll want to remember is aluminum forms 3+. So all the other ones are not as predictable. You might think that the whole nitrogen column would make -3, but it just doesn't. But these are the ones that you'll want to memorize, and I will again have a memory assignment for you coming up soon, but just to give you a little bit of a preview so that you maybe can start remembering. All right, before we close off this lesson, looking ahead a little bit, let's think about what predictions we could make for compounds. So what neutral compound could form between sodium plus and Cl minus? So if you have to take a certain number of sodiums and a certain number of chlorines, combine them together to make a neutral compound, how many would you need of each? Well, the sodium's +1, the chlorine's -1, so if you have just one of each, NaCl, then it ends up neutral. So there's no charge here because the plus and the minus cancel each other out. And when they cancel each other out, we don't write them anymore. Okay, they're just not there anymore. All right, so that one was familiar and maybe easy. Let's go for one more that's a little bit unfamiliar perhaps. What compound would form between Al3+ and O2-? Now again, you can take any number of Al3+, any number of O2-, and you have to do that so that the charges cancel. So how many of each? If you think it is Al2O3, you are right, because 2 times 3+ would be +6, and 3 times 2- would be -6, and of course +6 and -6 add together to 0, so you end up neutral. All right, that's it for the periodic table. I hope that you learned something today, and we'll see you soon.